Hi, this is the Year 8 Electricity and Magnetism Reverse the Classroom. Right, so this is then all the kind of information that you then need to know during the unit itself. And it's obviously going to help you if you kind of access it beforehand, so you've then got a good idea about what's going to come up, and then you'll be able to learn the information that's delivered in class better. Now this is the snaky diagram. We're going to be drawing circuits, current, potential difference and resistance, circuits themselves where you've got practicals to do. We've got current in a parallel circuit, magnets and electromagnets. Now what I'm obviously going to do is I'm just going to kind of go through the brief information about each one of those little sections. Now symbols, open switch, right, which is obviously a line, it's kind of got a little drawbridge going up, closed switch, a lamp, which is a bulb, a fuse, and the key to that is the fact that going through the middle there, right, there's a line, the cell, a voltmeter, a V in a circle, an ammeter, an A in a circle, a battery, right, if you compare a battery to cells, and sometimes also what you do is if I actually draw a symbol for a battery, sometimes what they'll have is they'll have a little line there, they'll have kind of three little dots in between. A diode is then a triangle with kind of like a line going down it, right? So there's a line going down it there, and then you've got your line going all the way through, which is the electricity. A resistor, this is then where what you can do, if you look at the resistor and you look at the fuse, the difference between a resistor and a fuse is that you've got that little white line going through the middle, which is the way that a fuse works. A fuse has got a little wire kind of going through the middle that blows or burns if too much electricity passes through it. A thermistor is all to do with temperature. I sometimes think of this as like an ice hockey stick. A variable resistor, you've got your line sticking out the side, and that is then an arrow going through. LDR is a light dependent resistor. Okay, and you can tell that because it's got a resistor in the middle, right, which is the kind of the rectangle, and the lines shining in is light, and it's dependent means it's kind of going in. This one is then an LED, which is a light. Now the arrows are then going out, so it's a light emitting diode. And I know it's a diode because you've got diode there. Two different types of circuits. All right, a series circuit is one loop. So electricity comes out of there and it can only go around that route there. It's only got one route to go. In a parallel circuit, what it's got one route there, but then it's also got, when the electricity gets to here, it's also got another route that it can take. So a parallel circuit has got more than one route for the extra electricity to take, or the electricity to take. Now, definitions. Current is the rate of flow of charge. Right, and I'll always remember current as the flow. It's the flow of electricity. Potential difference, when I was at school, is always used to be called voltage, right? But now it's called potential difference. It's a measure of how much energy is transferred between 2 points. And I always kind of remember it as the push, right? It's how hard the electricity is pushed out. So if you've got a 1.5 volt battery and you've got a 9 volt battery, which one's pushing the hardest? The 9 volt one. Resistance is the opposition to the flow of charge. It's whatever's in the circuit that slows down the flow of the charge. Right, magnets. Right, so we've got our north and we've got our south. Strongest fields are at the poles, which is here. Right, you can see that because all the kind of lines are squashed together. But the magnetic field always goes from north to south, always. And what you have to do, you have to put the little arrows on. So even these ones here, what they do is they then can make a big loop around here and they can come back to here. All right, so the strongest fields are at the poles and the magnetic field always goes from north to south. An electromagnet, okay, we just talked about magnets, got north and south, right? If you actually pass current through a wire, what you do is you get a magnetic field, right? So it says here to the battery, so what I've got here is I've got my battery there, right, do that a little bit bigger, right, well that's a cell more than a battery. Electricity could go up there, it then goes round this coil here, and then it comes back out here. As soon as you do that, what happens is it becomes a magnet, an electromagnet. And you can see that because you've got iron filings actually sticking to the end of that nail. And putting the nail down the middle, what that does, it concentrates the magnetic field. But then obviously the advantage of it is when you turn the electricity off, the magnet turns off. Use of an electromagnet is in a doorbell. Now what you've got to do here is you've got to kind of just sort of look at it and picture it a little bit about what's actually going on. Right, so electricity, what it does, it flows down here, it goes around the coil, right, which makes an electromagnet, it goes up to here, it goes up to here, and what it does, it goes through this kind of armature here, and then through this kind of little button. And then what it does, it goes all the way back here. Right? And so when you've got that electromagnet on, which is when the electricity is flowing, what happens is this electromagnet here attracts that blue arm, because that blue arm is then made of iron. It's like an armature. That, in turn, dings the bell. But when this armature here moves towards the electromagnet, what we then do is we get a cut in electricity here, so the current breaks. And when the current breaks, the electromagnet then turns off, and then the armature goes back towards the screw. Current starts up again. Okay, so that is then briefly how an electromagnet works. Now these are then the questions. What you've got to do is you've got to write these down in your exercise books. Question number 1 is, what is potential difference? I just want a definition. Question number 2, draw the symbol for a diode. I want the symbol drawn nice and big for a diode. Number 3, how do we create an electromagnet? Number 4, where are the strongest fields on a magnet? Number 5, draw a thermistor. Now those questions are reasonably straightforward. All right, so the most important things on this is learn the symbols. Okay, and then it's understand current, potential difference, I'm going to be lazy, and resistance. Right, they are kind of the big topics that then need to be understood when you're actually going through this.